Okay, we are going to be discussing molarity and the concentrations of solutions. So I guess the first equation, which you definitely need to memorize, is molarity is equal to moles of solute over liters of solution. Now, what is solute? You'll recall that solute is that substance which is dissolved within the solvent. It's the smaller part of a solution. So we can use this equation to solve a variety of problems. Let's try this one. What is the molarity of barium iodide? Barium ion and chloride, actually iodide ion, if 46 grams of barium iodide is dissolved in 500 milliliters of solution. So we're looking for the molarity, or the concentration of this compound and the ion. So we're going to use, again, molarity is equal to moles over liters. Now, do we know how many moles of barium iodide we have in this solution? No. Initially, we just know the number of grams. We know there are 46 grams of barium iodide. So how many moles is that? Well, I guess we need to go from those grams into moles. So let's use the molar mass of barium iodide. It's 391.1. So you can calculate then that you have 0.117 moles of barium iodide in solution. So now you know the number of moles of barium iodide. And how many liters do you have? Do you have 500 liters? No, you have 500 milliliters. So so how many liters is this? I guess there are 1,000 milliliters per liter, and so 500 mils divide by 1,000, and you have 0.500 liters of solution here. So how many, or I guess, how many moles per liter, aka how many molar, or what is the molarity? It's 0.234 molar barium iodide. So what's the concentration then of your barium ion? Well, each time that barium iodide is dissolved in solution, you get 1 barium ion and 2 iodide ions. So the concentration, or the number of moles per liter of barium, is the same as the number of moles per liter of barium iodide. It's 0.234 molar. But the concentration of iodide, well, it's twice that of the barium iodide. So each time barium iodide dissolves, you get 2 iodides. And so the concentration of iodide is 2 times 0.234 molar. It's 0.468 molar. Okay. Next question. How many milliliters of 0.234 molar barium iodide solution are needed to add 3.21 grams of barium iodide to another solution? So you want to add a certain number of grams of solution. In order to determine how many milliliters of solution you need to add, you'll need to know the number of liters of solution, which, knowing the molarity and the number of moles you add, you can get to liters. So I guess we need to rearrange this equation to isolate liters, get it alone and on top, and so multiply both sides by liters and then divide both sides by molarity, and you get liters is equal to moles over molarity. How many moles of barium iodide are we trying to add? 3.21 grams into moles, and that gives us 0.00821 moles of barium iodide we're trying to add. And the molarity of the solution we know is 0.234 molar. So now we just can divide, and we find that 0.0351 liters of barium iodide solution are needed. But the question is asking how many milliliters. And so we need to convert those liters into milliliters. 1 liter is the same as 1,000, or 10 to the 3 milliliters. So multiply by 1,000, you get 35.1 milliliters of barium iodide solution are needed. Next question. How would you prepare 500 milliliters of a 1.75 molar solution of sulfuric acid, starting from 8.61 molar stock solution of sulfuric acid? So how would you get a dilute solution from a concentrated stock solution? Well, we can use an equation to do dilution problems like this. But before I introduce that equation, I just want to introduce the concept. You see, we're taking this stock solution. Now, generally in the back room, I have concentrated solutions, which later can be diluted to give a variety of different dilute solutions. Now, you can't take it the other way. You can't take a dilute solution and turn it into a concentrated solution. That would require removing water, which would only be feasible upon boiling off some water, which is a pain. And so we start out with our concentrated solution, and we want to get this dilute solution. So we want to essentially add water to this concentrated solution to get the dilute solution. Now, here's the question. Is the number of moles of that solute the same before and after you have added water? Well, solute, recall, is just this barium iodide dissolved. It's the smaller part of the solution. If you add water, the solvent, the number of moles of solute doesn't change. And so the moles of solute before and after the dilution is the same. Now, also recall that because molarity is equal to moles over liters, moles is equal to molarity times liters. So replace moles of solute with molarity of that initial solution times the volume of the initial solution. And then do the same for the final solution, and you get this important equation here for dilutions. Anytime you see the word dilution, you're going to think of this equation. Molarity of the initial solution times the volume of the initial solution is equal to molarity of the final times the volume of the final solution. So again, the question is, how can we prepare this new dilute solution of dilute solution of sulfuric acid? And so what we want to do is start by using a volumetric flask. This is a flask which has a line in a very precise point, so that if you fill the solution to that line, you have precisely 1 liter or 2 liter, whichever that volumetric flask is designed for. And so you're going to start out with that initial concentrated solution, however many milliliters or liters of that concentrated solution, and then you're going to pour in the other solution. Now, I guess generally what you want to do when you're dealing with sulfuric acid is you want to add the acid to water for safety reasons, because if you add water to the acid, it's going to increase temperature way too much and start boiling over. Now, with a volumetric flask like this, though, what you first want to do is, in a separate container, add that sulfuric acid to water until perhaps you get it to some point of fairly dilute solution, and then you fill this container with that, and then add a little bit more water until you have precisely that number of milliliters or liters that you need. Okay, so 500 milliliters. Okay, so getting back to this equation, how do we do all this? We're going to start out with a certain number of milliliters of our initial concentrated sulfuric acid solution. Then we're just going to add water to it. So really the question is, how many milliliters of the fairly concentrated sulfuric acid solution do we need? So use our equation, isolate VI, volume of the initial solution. And then you can start plugging in. Now, the molarity that we want is 1.75 molar. The volume that we want is 500 milliliters. And then the molarity of the initial solution was 8.61 molar. Okay, so is it possible for you to use milliliters in this equation, or do you need liters? Well, as long as you're consistent with units, either one should be fine. So if you plug in milliliters here, it's gonna chug out after molarity is canceled out. It's gonna chug out milliliters as your unit as well. So that's just fine. So you should calculate 102 milliliters. So again, initially start with 102 milliliters of the 8.61 molar solution. Add water to it until it's a little bit less than 500 mils. Then pour it into your container, your volumetric flask. Then fill to precisely that mark, and you'll have 500 milliliters of precisely 8.61 molar, actually 1.75 molar sulfuric acid. All right, guys, thanks for watching.